Микрофон включен. Алло.
Good morning, all participants our conference. We are started the next day of third international conference on design simulation manufacturing, the Innovation Exchange. The next session is session number 3, chemical engineering. I am a session chair. My name is Alexander Pochenko. In this session, we have 5 presentations. The first speaker is Елизавета Черныш from Sumy State University. Improvement of the model system to develop eco-friendly bioutilization of phosphogypsum. The second speakers are Valentina Tkachuk, influencer from Lutsk National Technical University, influence of high-octane bioadditives on physical and chemical properties of low-octane gasoline. Next speakers, Professor Vladimir Zavyalov from National University of Food Technologies, substantiation of energy parameters of continuous action vibroextractor for solid liquid systems. And next speakers, Irina Vaskina from Sumy State University, influence of the magnetic fields, radiance on the efficiency of magnetic water treatment. All listeners can use a chat of YouTube or Facebook to ask questions or write comments. Begin. The first speaker is Елизавета Черныш from Sumy State University. His research is improvement of model system to develop eco-friendly bioutilization of phosphogypsum. Please.
Now you hear me? Yes? So thank you for introduction. I'm pleased to present your attention this topic. This topic is joint research with our partner from Chubu University, from Bioscience College, Japan. It's Hasegawa Sensei, and about some challenges under this topic. This next slide, second slide, please show. Because I don't see you show me my slide. About major challenges. I want to note it about phosphogypsum as this waste or some mineral sources, how we can use this type of byproducts. Especially phosphogypsum is a phosphate fertilizer industry solid byproducts. And the amount of phosphogypsum grows rapidly, and now in Ukraine especially is more than 45 millions of tons phosphogypsum situated in the large territory under dumps. And general is not problem from Ukraine, but now it's a problem since worldwide, mostly in the 42 countries phosphogypsum dumps in, and recycling of these byproducts only maybe 10%. So it's the actual task to recycling such type of byproducts. And now our research, it's this next slide. You can show aims and research task. Research aims. The modeling of the possibility of alkali growth under mediums that contain different phosphogypsum doses for environment protection purpose. About alkali growth and sort of biological object we choose because it's have a very interesting industrial application in different type of bioprocesses, and especially about environment protection system in under bioremediation technologies, and wastewater treatments and destruction carbohydrates. So we're using such type of biological objects, alkali, and different type of phosphogypsum doses includes to the mediums. The following tasks need to be addressed: modeling and analysis of the effect of phosphogypsum features and estimation of alkali growth, developing the methodological approach of the estimation bacteria growth under the mediums that include phosphogypsum. So it's our task. And about some method and methodological processes of investigation. Please, next slide. You can show because I don't see you. Research methodology. Yes. Now you see the slides. Some moments it should be noted. Mostly you can see they are staged in the slides, but first of all, our colony of alkali was picked up and transferred into the Libya media culture and cultivated under 37 degrees Celsius. It's most often very convenient temperature major for these bacterial groups, and now we under this process we include different doses of phosphogypsum. You can see it's the most 250 milligrams per 200 milliliters, 500 milligrams, and 100 milligrams. So it's types of choosing our dosage and initial optical density at 600 nanometers of 0.05 as initial column. So the next stage, of course, the incubations of these needing conditions, every 5 hours and after 25 hours, measure its optical density using the multi-spectrum of photometers, and of course we use some other equipment in scanning electron microscopy to analyze its composition and so forth, morphology of samples, and general bacterial growth experience were repeated 5 times independently to analyze the effects of phosphogypsum on bacterial growth, and we use in taxonomic classification, and for this type purpose electronic database at Kyoto, Encyclopedia Genomes and Genomics, and us. In the next slide you can please, next slide, show results. It's a modeling and analysis of effect phosphogypsum, common estimation of the alkali growth, and we see that different types of optical density rapid growth in different dosage of phosphogypsum. It should be noted that phosphogypsums have some specific features, chemical features that firstly influence on the evaluation of the effect of estimation optical density. Because it's not very good soluble, it's so it can it is impacting on processes of growth alkali estimation, and most of all, if you show the next slide. When present in figure 3 some image of phosphogypsum samples and ADC spectrum of the fields, we can understand about these effects not very easy and have some progression and difficult conduction. I hope okay, and you can hear me and see my presentation. Yes?
Yes, of course.
And okay, so we see the structures of phosphogypsum samples, and in these structures, gypsum crystals and silicates or limosilicates included. And analysis mineral composition, it's most important. Phosphorus, sulfur, calcium presented on the phosphogypsum samples, and some of contamination can be metals, ferrum, cuprum, of course also, and it's most of all interesting influence such minerals, nutrients for bacterial growth. Nevertheless, if you please next slide present, show me and modeling. We see the photos of tube after 24 hours of ecological cultivation. Yes, and of course, model of the face under culture medium phosphogypsum system. Should be noted that after 24 hours, all the substance convenience, if you see on the tubes, it's most of all have some similar tendencies. What does it mean? So phosphogypsum components can be used for E. coli for its growth. It's not only precipitation on the dump. So it's an interesting reaction, and we see in the diagram, you see the influence of phosphogypsum features on optical density and under the time, and we see some peaks that can be difficult impacted under precipitation of some components of phosphogypsum and some solvences components under bacterial activity, under growth, and about some biochemicals analysis of these processes. Please show next slide. Developing methodological approach of estimation bacterial growth under medium that included phosphogypsum. About this estimation, of course, it's needed to understand analysis bioinformation databases to consider and understand metabolic pathway of phosphogypsum conversions. The conversion especially is important how in organism of bacterial growth includes these elements from phosphogypsum for useful safety, for nutrients, and identify some enzyme systems that involve these processes. The next stage is genetic tools and estimation bacterial general of cultural, model of metabolic pathways, model of the reaction of catalysis by enzymes, determination of mechanism and regulation of phosphogypsum composition transformation. Is this general general models that can be used not only for E. coli growth, but for other biological objects. But E. coli is a most simple biological object that have rapidly growth, have a lot of biomass growth, and it's not it's easy to estimation possibility to use this type of biological object for analysis state of phosphogypsum conversion. Under this approach, please show next slide. We can see a model of biofilm formation factor based on the dates of the Encyclopedia of Kyoto Gens Genomes database, and we see some environmental singles. Firstly, yes, oxidative stress, energy supply, oxidative availability, low temperature, acidification. It's very interesting factor, acidification, because phosphogypsum have some influence on pH and in this influence condition can be changed to acidic condition. And volume stress, amino acid metabolism, osmolalite, and carbohydrate limitation. So this factor influence, and under these factors, growth biofilm. This growth of biofilms very important on the system of formation absorption system, bioabsorption system for destroy different type of pollutant, the contamination, ecosystem contamination. So in general, if we go to next slide, please go to next slide. Conclusions. We have some very important summarized information and result. Under model of phosphogypsum features influence several factors that identifies the impact of bacterial growth, the initial increase of the tubular culture mediums, different doses of phosphogypsum, and the rapid deposition of components bottom, increasing in turbidity. But partial splitting of the components of phosphogypsum in the medium during the time of cultivation and reduces sediments. It's very important. And after 25 hours, tubes of cultural medium phosphogypsum without it had approximately the same turbidity. And this was confirmed to the evaluation of optical density, and that means that phosphogypsum components can be used for seeds for growth, bacterial growth. The methodological approach was the development for assessing the biochemical activities of phosphogypsum for understanding fluence chemical features and metabolic pathways and optical density measures and the estimation possibility effect of fused composition phosphogypsum and medium growth bacteria in the assessment mutation adaptation biochemical mechanism. And this mechanism included to forming biofilm, and this biofilm is very interesting for bioabsorption processes in environmental protection technologies. So, of course, it should be noted that separation study of the metabolic pathway of strict anaerobic is necessary for providing specialist technology model of implementation on the wastewater treatment plants. So it's the most important conclusion. We, of course, continue such research and interesting possibility of different type of application of these processes can be. And please, next slide, acknowledgement. We thank Professor Platsuk for reading this manuscript and helping discussion, and Takahiro Hamaguchi from Chubu University for this technical support. And in general, this work has been supported by the fellowship program of the Mitsuma International Foundation, and I very thank you for this possibility to do this investigation together with Japanese partner in Chubu University and the research funding from Chubu University, of course, from Professor Hasegawa. So, in general, I very thank you for your attention. And then the last slide, it's only thank you for your attention. And I wait for questions. Thank you very much.
Okay, Elizaveta, thanks for your presentation. I look in the chat of live streaming of YouTube and Facebook. We have no questions or comments. Thanks. The next speaker is Associate Professor Valentina Tkachuk from Lutsk National Technical University. Influence of high-octane bioadditives on physical and chemical properties of low-octane gasoline. Please.
Good morning to all participants. Yes, it is a great pleasure for me to represent my report at this solid international scientific event. Me and my colleague present Lutsk National Technical University, and my co-authors Victoria Romanchuk present Lviv Polytechnic National University, and Nina Mareshko, Oksana Zolotaryova present Kyiv National University of Trade and Economics. So the topic of my report is influence of high-octane bioadditives on physical and chemical properties of low-octane gasoline. Please show slide. Next slide. Next slide. Modern cars require high-octane fuel with anti-knock properties, which are characterized by a research octane number of 92.95 and 98. For cars with gasoline engines with a compression ratio of up to 8, which are present in the fleet of Ukraine, as well as for trucks and of the previous generation, there is a need for gasoline with a lower octane number. The use of high-octane gasoline in cars with a compression ratio of up to 8 is the cause of a number of breakdowns. Failure of the piston fingers, paint and linear connecting rod and main bearings, cracking of insulation and burnout of contacts of spark plugs, burnout of the bottoms of pistons, burnout of working facets of exhaust valves and their seats, burnout of gaskets between the head and the cylinder block, burnout of piston rings and their increased wear. However, environmental safety and low cost of such gasoline remain one of the priority requirements in the production of gasoline. Next slide. The purpose of this work to assess the effect of bioadditives on the physical and chemical properties of gasoline fractions obtained from various oils, to determine the necessary amount of bioadditives and to achieve the octane number 80. Estimation of parameters of operational properties for mixed fuels is performed using standard methods of investigation of physical and chemical properties of fuels, which are standard for both oil and alternative fuels. Next slide, please. The main advantage of gasoline-methanol fuels is the reduction of nitrogen oxides, carbon monoxide, and other harmful substances in the exhaust gases of cars. However, the use of methanol in many countries is prohibited due to its high toxicity, volatility, and increased hygroscopicity, which also creates a number of technical difficulties when using alcohol-gasoline mixtures. Bioethanol is a less hygroscopic product, which has more heat of combustion and less heat of evaporation. It is significantly less toxic than methanol. Its advantage also lies in the fact that it is made from renewable raw materials. However, ethanol has a number of disadvantages. Absolute ethanol is hygroscopic, also to a lesser extent than methanol, corrosive, negatively affects rubber and plastic parts. Biobutanol can completely replace gasoline in internal combustion engines. In terms of technical characteristics, biobutanol is superior to ethanol to heat of combustion is 25% greater than that of ethanol and 10% greater than that of gasoline. It is safe to use because evaporates 6 times less than ethanol and is 13.5 times less volatile than gasoline. It does not cause corrosion. Butanol has a low saturated vapor pressure and its mixture with gasoline is not as hygroscopic. It provides better fuel economy than gasoline-ethanol blends. Butanol will also provide lower greenhouse gas emissions into the atmosphere. However, obtaining this type of fuel is quite difficult. According to analysts, butanol can become an important part of the fuel market for transport. However, currently its production is at the initial stage of development. Isopropanol is characterized by high maximum allowable concentration, the octane rating values, has good physical stability in mixtures with gasoline and also provides physical stability of gasoline-ethanol mixtures. The addition of 6% isopropanol increases the octane number by the motor method of straight-run fraction of gasoline by 13. And the octane number... Наступний буде. Yes, and next slide shows the results. The addition of 6% isopropanol increases the octane number by the motor method of straight run more than 6%. Its effectiveness is an anti-detonator decreases. Methyltret butyl ether is widely used in the production of gasoline as high octane component. Octane number, according to the research method, 115-135 units and contributes to a more complete combustion of motor fuel without the formation of solid deposits on the cylinder walls of the internal combustion engine and prevent corrosion of the metal surface. The maximum legal content of MTBE in gasoline in the European Union is 15%. The addition of 10-15% MTBE increases the octane number of gasoline by an average of 6-12 units. Currently, the issue of environmental safety of MTBE application is very acute, in connection with which is homologous ethyl and butyl esters of terbutanol are considered as an alternative additive. Please, next slide. The undoubted advantage of ETB is its biodegradability in nature, as well as the possibility of using ethyl alcohol obtained from vegetable raw materials, bioethanol as a raw material. Physical and chemical parameters of bioapplications to gasoline are presented in Table 1. So, next slide. The above-mentioned biological applications were added to straight-run gasoline in the amount reaching the octane number 80 The results are represented in Table 2. Optimal formulations of low-octane gasoline with various bio-applications are proposed based on the prices of the components of such mixtures and the requirements for their quality. Next slide. The lowest cost will be in a mixture of straight-run gasoline and isobutanol, despite the fact that its content in the mixture is the highest. Next slide. Optimal formulations of low-octane gasoline with various bio-applications are proposed based on the prices of the components of such mixtures and the requirements for their quality. The lowest cost was in a mixture of straight-run gasoline and isobutanol, despite the fact that its content in the mixture is the highest. The amount of isobutanol in the composite mixture should be left in the amount of 4%, MTBE in the amount of 10%. Then the total oxygen content will be within acceptable norms. The content of the formate in the mixture is set at 29%. Analyzing the physical and chemical parameters of the resultant gasoline mixture, we concluded that this type of fuel meets the requirements of CCTU 7687/2015, that is, it can be used in gasoline engines of motor vehicles. Thank you for your attention.
Valentina, thank you. Thanks for your presentation. We have a question in the chat of YouTube channel from Maxim Kunitsyn. Next, on which engines were the experimental studies carried out?
Now we have investigations only in laboratory conditions. So we investigate chemical and physical parameters, and our next investigation will be based on motor engines. And we have in Ukraine a lot of motor vehicles which are old, which are not modern, and we can this problem in Ukraine. Maybe it's a Ukrainian problem.
Thank you.
Okay, thank you. Thank you for your presentation. We have no questions. Next speaker is Professor Vladimir Zavyalov. Research is substantiation of energy parameters of continuous action vibro extractor for a solid liquid system. Please.
Thank you. Dear colleagues, good afternoon. I'm glad to see you. My name is Vladimir Zavyalov. I am representative of National University Food Technologies, Department of Processes and Apparatus of Food Production. Dear colleagues, today at the Department of Processes and Apparatus, our team conduct research in the direction of purposeful intensification of technological process. One of such direction, the scientific substantiation of vibration extraction process in the solid liquid system. So the topic of my report, substantiation of energy parameter of continuous action vibro extractor for solid liquid system. Today the development is of industry under new economic condition is characterized by the development of complex system with the aim to use rationally vegetable raw materials and process them a larger depth, and by the introduction of waste-free and energy-saving technologies. For the most material-intensive food industries, such as sugar, oil, and fat, pharmaceutical industry, in which 1 million ton raw materials of vegetable root, fruit, berry origin are annually processed, these problems are particularly again. In connection with the foregoing one, the most efficient method of the intensification for the extraction process consists in using intensive hydrodynamic regimes. Among the known apparatus operated in these regimes, vibrator extractor are the most promising. Next slide 2. Другий. This picture shows a number of vibrator extractors of periodic and continuous action developed at our department. Vibrator extraction is next slide. Sorry. Vibratory extraction is a relatively new technological process. Its general theory is complex and still in its early stage of development. Therefore, the task was substantiated the influence of low frequency mechanical oscillation generated by the drive system on the energy consumption in a condition of vibration extractor of raw materials, and established request is that change depending on the design of mode parameters of the apparatus. Next slide. Research methods include experimental and analytical modeling. 5 slide. The power required to perform work during vibration mixing was determined by the electrical method and taken into account the losses on the active resistance of the motor driven by the equation. Next. On this poster, we can see the scheme of continuous vibrator extractor. The principle of operation of the device is demonstrated by the film. Film, please. Plant material is fed through the loading device under the bottom plate. Under the influence of vibrating plate and due to the difference of hydraulic resistance of the nozzles moves upward current extract which is fed to the upper plate and discharge through the device. Next. On this poster, we can see the scheme, a transport separation plant, and scheme of movement of a working stream in transport and filtering elements. Next slide. The total energy consumption for the processes can be determined by the equation. Next slide. Generalized view of the equation for the whole apparatus, and its equation have place numbers such as a pressure drop on both sides of the plate, and some coefficient of located hydraulic resistance, and another. Next. Investigation of the influence of regimes parameter of the device on energy consumption. Here it's necessary to tell that turbulent pulsating flow generated by vibrating elements are determined by the energy parameter and create optimal hydrodynamic condition of for counterflow mass exchange due in intensive micromixing in the cross section of the working volume of the apparatus, which minimum longitudinal mass exchange under extremely high turbulation in the zone of the plate. They develop a larger interface provided condition for intensive mass exchange. Next slide. This fact was substantiation by the experimental data on the determination of the level of longitudinal mixing for from the course to the introduction of tracer again. Next. The next poster, this depends on the transport capacity of the vibray extractor on the regimes and constructive parameters. The first course that sets the optimal number of transport elements from the performance of the device. The second determines the development of productivity on the intensity of oscillation. Next. The next poster is this. The depends of the specific electricity consumption on the oscillation intensity of the vibration transport system in the continuous process of vibration extraction. The first course for amplitude 15 millimeters, the second is 10 millimeters, the third 5 millimeters. It is established that the oscillation amplitude of vibration system has the most significant influence on energy consumption during transportation and phase separation. In addition, the nature of the course leads to the conclusion that the processes can be optimized. In other words, of the three given oscillation amplitude, the most favorable in the amplitude 10 millimeters. In addition, the minimum energy consumption for all three graphs also determines the optimal oscillation frequency. So see that for amplitude 5 millimeters, the optimal oscillation intensity is 40 meters per second, which corresponds to frequency 8 Hz. For amplitude 10 millimeters, the optimal oscillation intensity is 30 meters per second, a frequency of 3 Hz. For amplitude 15 millimeters, the intensity is 43 meters per second, a frequency 2.7 Hz. The power required to perform vibration mixing is determined by the fictitious forces, the oscillation, motion, and the resistance created by the viscous friction of the mixing device in the viscous works every month. The reports, next slide. The proposed vibratory extractor can be used in a different branch of food industry. For this, we have developed apparatus technological scheme of production of extracts from plant raw material. And next slide, on this in this poster, we can see a brief conclusion from the report. Thank you for your attention.
Thank you, dear Professor Zavyalov. Thank you for the comprehensive theoretical and experimental research results. Your contribution for our conference series is outstanding. Just for information, last year Professor Zavyalov delivered a keynote speech. We highly appreciate his contributions. Thank you. We have no question in the chat. The next and last speaker of our session is Dr. Irina Vaskina from Sumy State University. His research is influence of magnetic fields gradient on the efficiency of magnetic water treatment. Please, Irina.
Hello. Do you hear me?
Yes.
Yes,
You can start.
you can
Very
start.
nice to see you. I'm glad to see colleagues I met last year at this conference and the new participants. My name is Irina Vaskina. I'm a senior lecturer of Applied Ecology Department of Sumy State University. Our department is focused on the environmental engineering. And so the main direction of our research is biogas production, biotechnology process in waste recycling, wastewater treatment, and waste management. So today I want to present the results of our joint research with the Lublin University of Life Sciences. A year ago, we start our collaboration with this university, and the main direction of their research is wastewater treatment. So we decide to find their joint scientific interest, and I think we do it because we start our research in the field of magnetic water treatment. As we see on the result of our citation of our previous results, this topic is very relevant all over the world and has a great scientific interest in for worldwide. So let's start my presentation on the topic influence of the magnetic field gradient on the efficiency of magnetic water treatment. You see that today's situation all over the world is alarming about great water scarcity, and its problem is relevant for all countries, and both for Ukraine, Poland, and any country in the world. It requires innovative technologies to ensure a proper treatment of raw, processed, or sewage waters. To solve this problem, we need to identify the robust methods of purifying water at lower cost and with less energy. And at the same time, we should minimize anthropogenic impact on environment. And of course, magnetic water treatment is one of these perspective methods. This technology isn't the new one, but stay relevant. For today, magnetic processing widely used in the environmental protection process in European countries and America. But the main problem of the magnetic water treatment implementation is the lack of studies of the mechanism of MWT effects. The magnetic field has influence on chemical properties of water, on scale formation and morphology. It also can modify the detergency and the mineral fouling and accelerated coagulation of scale-forming particles. The results of different studies and the practical experiments of applying MWT prove that the effects of the magnetic water treatment efficiency do not increase in proportion with the magnetic induction. Please, next slide. So one of the indicators of an inhomogeneous magnetic field impact on an aqueous solution is a change in the kinetics of chemical reaction. So the main aim of this research is experimental studies the impact of determining magnetic water treatment parameters on the reaction kinetics of organic matter oxidation with ozone. Experimental studies carry out using oxalic acid solution. It's relatively slowly oxidized by ozone, which made possible to monitor the effectiveness of magnetic water treatment. The efficiency of MWT was defined as the increase in the efficiency of oxidation of oxalic acid relative to the usual condition of oxidation. Please, next slide. For the experimental studies, the laboratory stand was made. The working solution of oxalic acid is pretreated in the magnetic field. As a result, there are physical-chemical changes in solution, which affects the kinetics of further reactions. After the magnetic pretreatment, the solution is fed into the bubble column for common process of ozonation. A series of experiments were carried out according to a similar process scheme. The effect of each of the defined mode parameters was studied independently. And next slide. You can see here the general experimental parameters of the working solution and other parameters of the experiment. The inhomogeneity of the magnetic field in the magnetic devices was provided by the movement of the aqueous solution in the magnetic field, with a variation in the magnitude from minimum to maximum along the trajectory, and this trajectory it looks like depicted on the next slide. You see, it's some waves that illustrated the changes in magnitude. At a constant length of pipe section, the inhomogeneity of the magnetic field was ensured by a change in magnetic induction, which allowed to change the inhomogeneity of the magnetic field under constant other processing parameters. Please, next slide. The efficiency of magnetic water treatment depends on the processing time and the speed of the solution in the magnetic field. Such dependencies is complicated with the design parameters of MWT devices, such as placement of magnets, the length of the section with the magnetic induction drops. So the influence of the rate of magnetic induction change on efficiency of magnetic water treatment was analyzed considering all these parameters and one mode parameter, the speed of the aqueous solution. The dependence of magnetic water treatment efficiency on the rate of magnetic induction changes with consideration of the total duration of the process was studied by the largest increase in the oscillation efficiency of oxalic acid with ozone. Next slide, please. The results of the control experiment were based on the oxidation of oxalic acid by ozone after passing the solution in the magnetic water treatment device without switching on the magnetic field. Please, next slide. Statistical processing of experimental results allowed approximation of the regression equation of magnetic water treatment efficiency on the rate of magnetic induction change and duration of process that you can see on the slide. The efficiency of magnetic water treatment under duration from 0.5 to 1 second does not increase monotonically with increasing value of magnetic induction change, and reach its maximum in the range from 0.4 to 0.8 Tesla per second. The efficiency of magnetic water treatment decreased due to higher magnitudes of magnetic induction, even with constant other processing factors. It indicates the complexity of the relationship between efficiency of magnetic treatment and magnitude of magnetic induction. The efficiency of magnetic water treatment also does not increase monotonically with increasing of duration of the process. Thus, at constant values of magnetic induction change, increasing the duration of treatment from 0.25 to 0.5 seconds dramatically increase the oxidation efficiency of oxalic acid. At the processing time from 0.5 to 1 second, the oxidation efficiency does not increase significantly, and further increase in the duration is technically unreasonable. So on the next slide, you can see the main conclusion about our results. I want to note that the speed of aqueous solution in an inhomogeneous magnetic field is determined the conditions for the appearance of magnetic water treatment effects more than the magnitude of the induction of magnetic field. The speed of aqueous solution and the geometry of the magnetic field are closely related to each other and are one of the main parameters that determine the efficiency of the process. The duration of the magnetic treatment has a significant effect on the intensity of the effects, and efficiency decrease using higher magnitudes of magnetic induction. Increasing kinetics of chemical reaction after magnetic water treatment can be widely used in environmental protection technologies. It reduces reagents needs and it can increase the efficiency of purification of reagent treatment process, and it can reduce the deposition on heat exchange surfaces, can help remove the suspended particles from contaminated water during the coagulation, flotation, or filtration processes. So these methods, magnetic water treatment, very relevant methods to pre-treat their wastewaters, and we hope that we can implement this method on their in Ukraine. So at the end of my speech, I want to thank to all my co-authors, both from Summa State University and Lublin University of Life Sciences, for this big research and great results that we have. And also I want to thanks to Vitaly Ivanov and all the conference team for great organization of this online event, and hope next year we can meet in person somewhere. So thank you for attention. Please, if you have questions.
Thank you, Irina. Thanks for your very interesting speech and presentation. I look in the chat of live channel. We have no questions or comments. Thanks.
Okay, thank you very much.
Dear participants, now the session 3 chemical engineering is fully completed. The speakers delivered 4 presentations with their research results. Thank you very much for all speakers. Very interesting topics are discussed. Till 19:50 we have a technical break. We ask you do not reconnect live streaming channels. We will start session 4 materials engineering according to the schedule. Let's stay in touch.
Доброго дня. Доброго дня. Чутно?
Hello, dear colleagues, dear friends. We are glad to welcome you at the third international conference, Design, Simulation, Manufacturing, the Innovation Exchange, online from Kharkiv. Our session, Materials Engineering, is devoted to issues of material science. And first of all, I want to thank everybody who found the time and opportunity to attend our conference. It's really very important to us. And also I want to say thank you to General Chair of this conference, Vitaly Ivanov, and all conference team from Sumy and Kharkiv. I wish everyone interesting conference and hope you can find here a lot of friends. Now we have started our session Materials Engineering, and today we have 5 presentations. All presentations have to be in English. All speakers have about 7 minutes for presentation. After that, you will have up to 3 minutes for questions. And now I want to invite the first presentation, Olena Mikulic from Lutsk National Technical University, influence of weak shock wave on dynamic stress state of foam materials. A lot of friends. Now we have started our session Materials Engineering, and today we have 5 presentations. All presentations have to be in English. All speakers have about 7 minutes for presentation. After that, you will have up to 3 minutes for questions.
Good afternoon. It's very nice to have the opportunity to speak at such important scientific conference. I bring to your attention the result of research investigation of influence of weak shock wave on dynamic stress state of foam materials. This research was performed at Lutsk National Technical University. I am engineer and doctor, professor of applied mathematics and mechanics department of Lutsk National Technical University. Next slide, please. Good afternoon. It's very nice to have the opportunity to speak at such important scientific conference. I bring to your attention the result of research investigation of influence of weak shock wave on dynamic stress state of foam materials. This research was performed at Lutsk National. Yeah. So sorry for some technical problems. Can I continue? Please slide second. For the development of modern technologies of the production of foam materials make it possible to obtain suitable materials with the present rigidly hardness at the density. Therefore, foam materials and products from them have a wide application today. Besides, the technologies of obtaining foam materials with negative Poisson ratio have expanded. These materials also called oxidic. For obtaining such materials, use foam with low rigidity. Next slide, please. More studies of effects of different types of laws on such materials are experimental. Therefore, the problem of developing theoretical method of investigation of time variable laws influence of on strength state of form materials with defects is very important. On slide 3, the aims and the task research are present. Next slide, please. For the solving of the problem, we consider the medium with tonal cavity under the action of plane deformation. The model of research is present in figure 1. The problem consists in determination of hoop dynamic stresses of form media with tonal cavity under the action of time variable load. A structure of form material with positive and negative Poisson ratio are shown in figure 2 and 3 accordingly. Form media with positive Poisson ratio was modeled as a system of cellular elements as present in figure 4. Form media with negative Poisson ratio modeled as a system antral elements and as present in figure 5. This approach is known in literature as it is applied for molded form and porous materials. Boundary conditions of the problem are written as 1. The analysis of deformation in form materials under the action of external load, we used a slice of structure of positive Poisson ratio form before and after applying, which presented in figure 6. These results is known as literature. Analysis of these results confirms the possibility of presenting internal deformation as summation of translation and rotation displacement of microparticles. Each micro-rotation of particles of the medium is associated with their translation displacement. Besides, microparticles of a form medium cannot make micro-rotation without translation displacement. This is due to the structure of the form materials. For the solving non-stationary problem, as to the investigation of time variable load influence on stress state of form media with tunnel defects, the apparatus of coupled stress elasticity is chosen. In the framework of coupled stress elasticity, vectors macro and micro rotations are same. Next slide, please. The motion equation in the framework of coupled stress elasticity is written in form 2. We write the displacement vector as sum of potential and vortex functions and substitute it in the equation 2. We obtain two equations of hyperbolic and parabolic type in form 3. Using the Fourier transform for to equation 3 and using the presentation for function psi, we obtain equations 4 on base which we write the values of speed of shear rotations waves in the framework of coupled stress elasticity. Next slide, please. The Fourier transforms for displacement was chosen is form 5. Satisfies the Fourier transforms of boundary condition 1. We obtain the system integral equation 6, 7, where we separate the singularities in integration function for small value argument and apply Flamel-Suchotsky formulas for limited translation. For the numerical solvement of system integral equation was used the algorithm which based on mechanical quadrature method and collocation method. Next slide, please. For the determining of hoop and hoop dynamic stresses on the boundary of the defect in form media, we built analytical presentation in integral form 8, and for the determination and investigation of original of dynamic hoop stresses, we use discrete Fourier transforms. Next slide, please. Using the development approach, we investigate the effect of wave shock wave on dynamic stress state of negative and positive Poisson medium with tunnel cavity. To the model of problems in figure 8. For numerical calculation, we use the elastic constants which is obtained in the Vox, Ruges, and Lakes, required to describe isotropic Kosarat elastic solid. Structure of positive and negative Poisson form are shown in figure 9 and 10, and values of this elastic constant are present in slide. Next slide, please. The slide shows the distribution of normalized hoop stresses at several points on the boundary of the circular cavity. The left figure corresponds to the case of form medium with positive Poisson ratio. The right figure corresponds to the case of form medium with negative Poisson ratio. Form with positive Poisson ratio was modeled with using cellular elements. Form media with negative Poisson ratio was modeled with using reentral elements. Comparing the numerical results shows that the maximum values of normalized hoop stresses at the boundary of the cavity is smaller in 2.4 times in material with negative Poisson ratio than with in materials with positive Poisson ratio. Besides, the distribution of hoop stresses along the boundary of the cavity is substantially different for materials with negative Poisson ratio. Next slide, please. All mentioned results of comparing numerical calculation of dynamic hoop stress are presented in slide. Next slide, please. The main conclusion, according to the obtained result, again, when in the slide, among them, I want to make accent on some aspects. First of all, numerical calculation confirm that development approach allows accounting for the influence of microstructure of material for analysis of dynamic stress state of form materials with positive and negative Poisson ratio. Second of all, based on numerical calculation, dynamic stress state of structurally inhomogeneous materials depends not only the physical characteristic of medium, such as density and Young modulus, but also on internal structure, whose influence is determined by the Poisson ratio. Next slide, please. List of references used in the presentation is shown in the slide. Next slide, please. Thank you for your attention. I would also like to thank the organizers of conference for such a wonderful organization in difficult condition of pandemic of COVID, which present us with many problems that we must learn to solve in a limited space. I wish everyone good health and further scientific and professional achievement. Thank you.
Thank you, Olena, for interesting presentation. Dear colleagues, maybe you have a question to Olena. No questions. Thank you very much.
Thank you.
I invite to next presentation Yaroslav Kusy from Lviv Polytechnic National University. Optimization of the technological process based on analysis of technological damageability of castings.
Dear friends and colleagues, my name is Yaroslav Kusy. I represent the Mechanical Engineering Department of Lviv Polytechnical National University of Ukraine, and I represent results of my researches and researches of my colleague Vadim Stupnitsky, optimization of the technological process based on analysis of technological damageability of castings. Next slide, please. The quality parameters of mechanical engineering products are characterized by the dimensional it's not my presentation. The quality parameters of mechanical engineering parts are characterized by dimensional accuracy, quality parameters of surface layers, operational characteristic, and reliability indicators. Providing quality parameters of the product is a wide concept which is closely related with all sub-stages and stages of lifecycle support of product. The technological process has a direct and critical influence of the quality parameters of the mechanical engineering products from blend production to the final finishing technological operation. However, the process of forming of parameters of product surface quality, its operational characteristics and reliability indicators at the stage of its creation require joint theoretical and experimental researches. Therefore, next slide please. The research aim is to develop a methodology for design structure of technological process, taking into account and control of technological damageability of process the blend to the final product. The object of our researches is lifecycle support of product. Research tasks were development and methodology for designing the rational structure of technological process of products manufacturing, planning and realization of experimental researches, the rational structure of technological process by means of Lame-Hardness method. We use Lame-Hardness method to analyze the physical heterogeneity of the blend material structure. Next slide, please. According to this method, the degree of dispersion of the characteristic of the material and structure state, material mechanical properties after operation time at various stress levels is taken of the measurement results performed by identical devices and identical conditions, then absolute as a parameter of damageability. The scattering of the measurement results performed by identical devices and identical conditions is more represented regarding the correlation of the mechanical properties of the material and the structure state than the absolute values of the characteristic. This method is easy to implement using hardness as a mechanical characteristic. The hardness value is used for indirect evolution of properties. Homogeneity is the parameter that integrally characterizes the state of the material during processing the results of hardness measurements. Homogeneity is estimated by Weibull coefficient M. The higher value of the coefficient M corresponds to the lower hardness dispersion and the lower damageability degree. We propose to use the technological damageability W, described by means of energy approaches to the process of accumulation of damage as a criterion for the process analyzed during blend machining. Next slide, please. COVID stopped our experimental researches, but we only used aluminum alloy for casting. Casting were machined by end milling, and you can see two variants of technological routes, and you can see cutting parameters in table 2. Hardness wire measurement on the device TP5006 by means of a ball diameter 3.175 millimeters under the loading 588.6 Newton in each experiment. 30-35 measurements were performed. Next slide, please. We calculated the variable coefficient M and technological damageability in mass cut. You can see the change of variable coefficient M in figure 2. You can see the decreasing the variable coefficient after roof machining and increasing after finishing treatment. You can see the increasing the variable coefficient after semi-roof machining and after finishing treatment. Next slide, please. In contrast, the technological damageability, you can see increasing the technological damageability after the roof machining and it's decreasing after finishing treatment. Another figure 3b, you can see the decrease in the technological damageability after semi-roof machining and after machining treatment. Next slide, please. The main results you can see on this slide and another slide. We propose to design the rational structure of technological process of product manufacturing by means of LM hardness method. Using the technological damageability W as a criterion for the analysis during blends machining, we can choose the optimal technological operation during process manufacturing. Determine the layer of product material for cutting during manufacturing. Predict the behavior of product's material during substages and stages of life cycle support of product. Next slide, please. And the main conclusion you can see in this slide. The technological damages on the surface layer of the part during operation and after machining should be analyzed by the hardness dispersion. We propose to use the technological damageability described of energy approaches to the process of accumulation of damage for the process analyzed during blend machining. Further research should be carried out for a wider nomenclature of products and material to introduce the proposed technique, the model of mechanical engineering production. And another slide. Next slide. You can see reference for this researches. And next slide. The presentation is finishing. Thank you for your attention.
Thank you very much, Yaroslav.
Thank you. All greetings from Lviv.
We have, thank you. We have questions for you from Vyacheslav. On which engines were the experimental studies carried out? Oh, sorry, it's not for you. Questions, dear colleagues. Maybe you have a questions to Yaroslav. No questions. Thank you very much.
Thank you.
Now I invite to presentation next speaker is Oksana Titarenko from National Academy of National Guard of Ukraine.
Yeah, thank you very much. Do you hear me?
Yes.
Good morning, everybody. Good morning, everybody, and our colleagues and our friends. I would like to start off by expressing my pleasure and thanks to all of your team for hard working in our unusual situation. And with great pleasure, I would like to present two universities. It's our Polytechnical University, Kharkiv Polytechnical University, and National Guard of Ukraine, Academy of National Guard of Ukraine, and our collaboration work. As you see in our subject, it's actually a study of morphological features on the electric properties of plasma electrolytic oxidation coatings on D60T aluminum alloy. With my great pleasure, I took a second time a part in such conference, and last year we have discussed actually the main pros and cons of such kind of coatings, and the main reasons and main cons of this technique. It's actually economically viable process and environmentally friendly process, and it can be produced information of oxide coatings in lightweight metals such as aluminium, magnesium, or titanium, and gives a lot of different functional properties, useful functional properties such as wear resistance, friction properties, corrosion resistance, thermal resistance, and dielectric properties, and many others. That can be interesting and useful for such industries like aerospace and automotive industry, for restoring some worn surfaces of parts. Second, please, slide second. And for chemistry industry, for medicine, for microelectronics, different parts of implants, for example, or head sinks for measurement instruments, such kind of units for temperature measurement and control. And what's the most important for us, it's a machine tool and engineering systems. It's actually our goal of research. And on the third slide, please, we can see actually our aim and research tasks. It's some same picture of surface layer of some aluminium substrate and PL coatings on it, and it can be seen that it consists of three different parts: poro top layer, it's intermediate layer, and inner transition layer. Each part has different properties because of a large amount of porosity. The biggest porosity we can see at the porous top layer. It can be in different kinds, such as open porosity, closed porosity, or through porosity. And intermediate layer, it's actually our functional layer, which determines thermomechanical and tribological properties. And inner transition layer, actually through porosity, goes from our top layer direct to this inner transition layer. It's also well known that porosity is one of the most important indicators of resistance of each materials, and especially for our PL coatings. And the biggest negative effect can be seen in corrosion resistance. And we can see actually through porosity makes the corrosion resistance decreasing. And in general, it's also well known that through porosity reduces also wear resistance of coatings. But in some cases, for example, in some friction parts in lubrication mediums, some oils can be can be entered to pores of coatings, and it can be as some reservoir for accumulation these lubrication mediums, and it's very important for such such industries like medicine, for some dental products, as we see in the last slide. And much less attention actually was paid to research about dielectric properties. So dielectric properties of aluminium alloys was studied by us with connection of interesting process like diamond sparked grinding or electroerosion diamond grinding. Such process was widely discovered and researched last century at the Institute of Cutting Tools and Cutting Materials in Kharkiv Polytechnical University. And actually, each decade was added to study of some diamond grinding wheels. And as you can see at the right side, it's a typical metal bodies of diamond grinding wheels with pale coatings at the middle. And for us, it was the aim of our research how to make such coating more viable, more dielectric. Where can we find the most effective conditions? Because we have a large amount of different sources for influence sources. For example, electrolyte composition and concentration, base material structure, processing time, temperature, current density, and others. And at the next slide, please, slide 4, you can see our laboratory installation of processing of pale coatings formation. We have used aluminium alloy, flat rolled samples. We have used transformer source under galvanostatic mode with anode current, and you can see at the right side electrolyzer with some solution and cathode steel ring, and anode it's our samples, aluminium alloys. And in this electrolyzer we have different kind of alkali silicate solutions. One of them is liquid glass, 0 to 12% gram by liter. The second one is 2 gram by liter potassium hydroxide and 12 gram by liter liquid glass. And third one is 1 gram by liter potassium hydroxide and 6 gram by liter liquid glass. We have named it accordingly to a slide. It can be seen further. And our coating thickness was measured with eddy current thicknesses. The results, it's in from 30 to 45 micrometers. And the most important for us was the indication. How can we see porosity? First of all, our through porosity, and for this purpose we have used contact copper insulation solution. So each samples after formation of PO coatings were immersed in this solution, and after different time and drying process, it can be seen on the next slides our results. For morphology and surface searches, optical microscopy and scanning electron microscopy have been used. Next slide, please. Our research of dielectric properties. Actually, we have used standard methodics for volume resistivity and electric strength. You can see our equipment, and in the picture our scheme, how have we measured. The most interesting things that for one volume resistivity measurement, we have used some contact electrodes and copper collector, and for another, for electric strength measurements, we have used other devices such as high voltage transformer, protective resistors, and device for smooth voltage. And after that, everything was calculated according to equipment. Next slide, please. And our results. Under constantly current density with 10 ampere per by decimeter, it can be seen the large amount of porosity, especially in the concentration 2 to 12. In the middle of this slide can be seen we have large numbers of systematic open pores with 2 or until 10 micrometers, and it's regular through porosity that can be that can have actually negative effect of our dielectric properties. Less porosity can be seen on the right side. It's our solution 1 to 6, and the smallest porosity and regular and lowest porosity we have in the left corner, our 0 to 12 gram to liter liquid glass. Next slide, please. At the next stadium, we have research. Seven. It can be seen influence of our different kind of current density from 5 to 15, and it also it can be seen that through porosity increases in each electrolyte. Especially in our middle 2 slides, in electrolyte 12 to 2 to 12. And actually, electrolyte composition is a major factor of this formation of through porosity. And after such researches, we started to research our dielectric properties. Please, slide 8. And it can be also seen a good correlation between these measurements, our morphology and dielectric properties. So, for example, the lowest volume resistivity we have in samples with biggest and largest amount of through porosity. We can be noticed also the significant dependence of volume resistivity on electrolyte composition, and the same also situation is with our electric strength measurements. Actually, it's in analogy to our previous research. We can see the versus results of 2 to 12 hour electrolyte, and as a result, we can also see that this electric strange is more sensitive to our electrolyte composition. And our results, and in conclusions, we have next slide, please, 9. It can be seen that we have a qualitative correlation between the nature and through porosity in the coatings with the electric properties of our aluminium samples. And increased porosity is one of the major factors for decreasing our dielectric properties. And for producing, maybe for future, it can be also interesting use our 12 gram by liter liquid glass solution as a technical solution for achieving the best results of our dielectric properties. And at the end, please slide 10. I would like to say big thanks for my colleagues, Елена Свидова, Larisa Pupan, Yuri Gutsalenko, Alexander Rudnev, for collaboration, for inspiring, for supporting, and for our future, maybe our also interesting collaboration. Yeah, thank you very much. Maybe some questions? Please.
Thank you very much for interesting results and interesting presentation. We have a questions for you. Vyacheslav, have a question. Sorry, but I didn't understand the role of diamond circles.
It's a typical grinding wheels for abrasive grinding process. So we have used aluminum samples, and actually this material can be used for production aluminum grinding wheels.
Thank you. And one question from Maxim. Did you have any problems with adhesion between coating and main material?
We can say that there are many problems here because our results we could not use for big samples. For example, in this case, we would recommend other current density and other operation time. But for future production process, for us, it was important to find actually the solution. What kind of solution we became the best dielectric properties. And what also was interesting that actually this process, plasma electrolytic coatings technica, can be used in different parts without big requirements to surface quality. And that is why it's widespread in different parts of machining tools.
Thank you very much, Oksana.
Thank you.
We have no questions. And now I invite next speaker to presentation, Maxim Kunitsyn from Odessa National Polytechnic University.
Hello, dear colleagues and participants. The theme of my report is research of thermomechanical processes when processing cylindrical surfaces with wear-resistant coating. Please slide second slide. Okay. The use of modern methods for producing very resistant coating using composite material based on compounds such as oxides, nitrides, and carbides are today a promising direction for the development of surface trenching technologies. The creation of hardening coatings from dissimilar materials leads to the formation of fundamentally new composite material of the surface layer, which has not only high strength but also sufficient ductility as well as increased wear resistance, and not only the modification of surface layer. Slide 3, please. The purpose of the work is to analyze thermomechanical process in the treatment of cylindrical surfaces with wear-resistant coatings. To do this, we perform the following main tasks. To develop an analytical model for determining the thermomechanical state of the working surface of a cylinder with a wear-resistant coating having sections of partial delamination during application. Consider the possibilities of technological support for the quality of finishing of working surfaces of cylinders using coating of wear-resistant material. To determine the influence of cylindrical groups processing regimes with a wear-resistant coating on its physical and mechanical characteristics. Slide 4, please. Determine the dependence of stress intensity factor on the delamination angle alpha and the working area of the cylindrical surface. Determine the effect of particles on the wear resistance of the coating deposits by the electrochemical method. Carry out triple corrosion studies of composite materials based on nickel titanium dioxide obtained by electrochemical deposition. And the last one is determine the dependence of the formation of cracks on the surface of the processed surface on the cutting depth and characteristic of the tool. Slide 5. To solve the problems, a particular case of the cylinder coating system was taken. This slide shows the basic analytical scheme for determining the stress strain state. On this scheme, number 3 are areas of absence or exfoliation of the coating. Furthermore, an analytical model was developed up for solving the thermal problem and determining the stress strain state of the system. Slide 6. This slide shows the influence of various processing modes of work surfaces with a wear-resistant coating, which provides the necessary roughness to maintain the functional properties of the coating. Slide 7. Using the correlation between the roughness of the working zone of the cylinder and the size of the delamination area of the coating during various finishing operations such as finishing and finishing grinding as well as polishing, the dependence of the stress intensity factor on the delamination angle alpha and the roughness of the working zone of cylinder surface was found. Slide 8. Dependence of the stress intensity factor on the relative distance between the sections of delamination during longitudinal shear. In the case when, due to the roughness of the working surface, there is a system of sections of delamination of coating from the base material. It's possible to change the stress intensity factor due to their mutual influence. Slide 9. The analytical model for the study of relationship between the relative distance of the detachment sides and the stress intensity factor is shown on this slide. It should be noted that the stress intensity factor can reach significant values without disturbing the equilibrium state, since the distance d increases and the coefficient 2 alpha d decreases. Slide 10. The tribological and the tribocorrosion studies of the composite coating were performed. The following figures will show some scratch profiles, their width and height with different exposure time. Naturally, with an increasing in exposed time, the profile geometry increase. Slide 11. To confirm the analytical model, several model experiments were carried out. For this, a very resistant nickel titanium dioxide-based coating was applied to duplex steel by electrochemical deposition. It should be noted that the application of very resistant coating to duplex steel was accompanied by some difficulties associated with the distinctive properties and characteristics of duplex steel itself, what added to desire for a more detailed study for its issue in future. Next slide. Electrochemical deposition of coating was carried out using the Afterlab scientific complex and NOVA software with the following parameters, which can observe on this slide. To save time, I will not stop on the slide in detail. Next slide. Summarizing the previous, we present an analytical model showing the relationship the temperature during the processing of wear-resistant coating of cylindrical surfaces, coating processing parameters, geometric parameters of coating defects, in additional the characteristics of the treatment coating. As can be seen with the indicated axis of these parameters during coating treatment, the wear-resistant coating is destroyed. Next slide, please. Various grinding wheels were used to determine the dependence of crack formation on the depth of cut and the characteristics of the tool. The distribution of cracks on the surface of wear-resistant coating treated by grinding depending on the depth of cut and the characteristics of the tool are shown in on this figure. The figure shows that the most productive tool for processing wear-resistant coating while maintaining the quality characteristics of wear-resistant coating are number 6 and number 7, which allows us to process the surface at great depths of cut. Next slide, please. Short conclusions. An analytical model has been developed to determine the thermomechanical state of the working surface of a cylinder with a wear-resistant coating, having partial detachment areas during application. The possibilities of technological support for the quality of finishing processing of the cylinder working surfaces using coating of wear-resistant materials are considered. The influence of cylindrical groups processing regimes with wear-resistant coatings on its physical and mechanical characteristic is determined. The dependence of stress intensity factor on the delamination angle alpha and the roughness of the working area of the cylindrical surface is presented. The effect of particles on the wear resistance of the coating deposed by the electrochemical methods is dependent. And next slide, please. Triple corrosion studies of composite materials based on nickel titanium dioxide obtained by electrochemical deposition were carried out. The dependence of crack formation on surface of the surface processed by grinding under the cutting depth and tool characteristics is determined. And last slide, thank you very much for your attention. If you have any question, I will be happy to answer them.
Thank you, Maxim, for great presentation. Dear colleagues, maybe you have questions. We have no questions, Maxim. Thank you very much.
Thank you very much, you too.
And now I invite to presentation next speaker, Yaroslav Garashenko from Kharkiv Polytechnic Institute. You are welcome, Yaroslav. Хорошо. Я объявляю перерыв. Dear colleagues, now we have technical break, about 15 minutes. Thank you.
Сейчас тут пару минут еще есть у нас.
Виталий, когда может быть это самое в Скопусе?
Пішли?
Yes.
Dear colleagues, let me introduce the next session. I will chair this session with title Interdisciplinary Research Engineering, and also, unfortunately, Professor Machado did not connect us in time. Maybe later he will change me, but anyway, we will start this session, and I would like to give some information about the reports in this session. The first presentation will be from a representative from Kyiv Polytechnic Institute, named after Sikorsky. The title is Ultrasonic Technology of Impregnation and Dosing Application of Liquid Epoxy Binders on Fabric Fiber Fillers. Professor Alexander Kolosov is the speaker of this session. Dear Professor, please, your presentation.
Thank you very much. Welcome to everybody, but despite on hot weather, we would like to continue our conference. As you know, the rectoplastic polymer industry, it's the culture and other strategic sectors of modern techniques and technology. And more widely, these constructive PCMs are obtained on impregnation drying machines, containing in particular with more important units, impregnation and dosage units. And according to our investigation and articles of foreign scientists, we know that mechanical vibration in the ultrasonic range or ultrasonic vibration in cavitation mode is one of the promising methods for physical action of liquid and solid components. Please, next slide, number 3, aim and research task. Aim and research task of our investigations are on modern high-speed impregnation machines, ensuring uniform impregnation and maintaining the necessary contained binders contained in impregnation fiber filaments is a difficult task. And for example, can we change speed of impregnation of fiberglass by 1.1 meter per minute? As a result, increased polymer binding contents, on average, it's on 1%. It's serious technical problems. And we know that our elaborating is create the advanced US technology for impregnation and dosing application of liquid epoxy composition on construction of fabric. Research methodology. We use industrial epoxy compositions, for example, at the 10 grade of hot current, which consists of epoxy oligomer, plasticizers, hardener. As US equipment, we research methodology, please. Research methodology, slide number 4. As US, sorry. Okay. US equipment, we use ultrasonic generator with output power 4.5 kilowatts, magnetostate transducer, which were and calculate determination epoxy composition content of impregration fiberglass fabric and coefficient of structural homogeneity. Please, next slide. Measured parameters of for dosing application where epoxy composition preliminary sonicated time was about 30 minutes, temperature of sonicated from 60 to 70 centigrade, temperature of epoxy binder in impregnation bath is different, meaning was about 30 centigrade, and we calculate US frequency from 18 to 22 kilohertz, intensity and amplitude in the showed parameters. More important parameter was fabric material pulling speed from 0.2 to 0.35 meters per second. And the next important parameter is epoxy composition content in impregnation fiberglass. It was from 35 to 40%. Please, next slide. On the next slide, please, we can see the general scheme of experimental device of ultrasonic and impregnation dosing application. We can see that this machine consists of the impregnation bath, the tanks for sonicated epoxy composition, submersible rods, winding reels, envelope rolls, squeezing rolls, drying chamber, which consists of several temperature zones, for example, from 100 to 130 centigrade, and then receiving reels, pair works of ultrasonic instruments, and ultrasonic generator and alluvial rolls. Please, next slide. The next slide presents different arrangement scheme of emitting plates of the dosing device relative to impregnating fabric filaments. Please, next slide. Results and of dosing applicate are presented on the next slide. We can see the next parameters consist of polymer binders and coefficient homogeneity, coefficient of content of epoxy polymer binders. This result can we see on the next slide, please. Within the table, technology comparison chart of amount polymer binders application in the fabric materials when consist of polymer binders is 35%. Indicator, we can the more important indicator drawing speed, and for traditional technology is about 0.012 meter per second. But according to the developed technology, we can increase it at more than 2.5 times. It's more important, so we can increase the productivity of our technology. And the next important parameter is application variation coefficient. For traditional technology, it's about 18%, but according to our technology, it in the range from 4 to 5%. So it's decreased about from 4 to 5 times, and we can use the viscosity of our polymer composition more than on 20 to 30%. Please, next slide. And conclusion, we can statement that our technology leads to the following positive results: the removal lubricant layer from the surface before its pre-impregnation with liquid epoxy compositions, and simultaneously we can obtain improving wettability of impregnated fiber filaments, and the next important result is removal air inclusions from structure of fiber filaments. The next result is epoxy composition degassing and the peristaltic nature of the motion of the fiber, both of the surface and the cross-section of the impregnated filaments. Next, possible to use highly viscous and highly concentrated impregnating polymer compounds, and as well as composition with short fiber furrows. And the last one is possible to obtain a constant and the most important predetermined content of epoxy composition in the impregnating fiber filaments with varying of pulling speed of the filler in the impregnation path. Please, next slide. Reference, we can see reference which are both published in Scopus and please, the last one, thank you for your attention. If you have any questions, you can please call me or communicate with me via electronic email. Thank you very much for your attention. Question, please.
Thank you very much, Professor Kolosov, for your interesting, comprehensive research results. I would like to highlight that you are our you participate in all our conferences, and thank you very much for your contribution to this edition conference. Now I can see that no questions in the chats, so thank you very much and looking forward to seeing you next year.
Okay, thank you, because I just prepared my report for the next conference.
Thank you very much.
For your start.
Thank you. Nice to meet you again. Thank you. Bye.
Bye.
We would like to proceed to the next presentation, and our participant from Kharkiv, host institution of this conference, Sergei Kononenko, who represents the team of scientists in collaboration with Professor Dobrotvorsky, Dr. Basova, Dr. Dobrovolska, and Professor Yepifanov from National Technical University Kharkiv Polytechnic Institute. Sergei is ready to deliver his speech with the title Simulation of Thin-Walled Parts and Milling with Fluid Jet Support. Now, Sergei, are you ready? Please start your presentation.
Okay, do you hear me?
Yes.
Hello everyone, I'm Sergei Kononenko, PhD student of Kharkiv Polytechnical Institute, and research is dedicated to simulation of thin-walled parts and milling with fluid jet support. Thin-walled parts are used in different branches of industry, and major challenges in production are complexity of errors prediction, geometric deviations, vibrations. They all malleable to deflection, and as a result we get poor surface quality. It's hard to achieve technical requirements. There are factors to consider in machining, and the first one is vibration. On the left side you can see defects, rough feed lines, chatter marks. On the right side, an example of surface quality obtained from profical profilometry analysis of thin-walled part. These probes were taken from the fixed, middle and free end of the wall. It shows that roughness of the surface increased towards the free end of the wall. It proves that stiffness distribution isn't uniform. And in these terms, the support of such kind of critical zones is interesting to investigate. Next slide, please. Next slide, please. Okay. Other factors of the deflection are cutting force and heat transfer. rational use of coolant is significant role in reduction of thermal deflection. In this research, we more focused on vibration and force impact. Aim and research tasks. So we formulate the fluid jet support model, and we need to investigate advantages of fluid jet support, appliance of smooth particle hydrodynamics in modeling, and as a result, we'd like to theoretically predict the oscillation amplitude for conventional machining and the machining with fluid jet support. Next slide. Research methodology. There is 4 steps in research methodology. We perform deflection force analysis, cutting analysis, and model and harmonic response analysis. On the first stage, we get impact of the jet on the thin walled element. On the second stage, we get cutting forces and stresses. In the process of model and harmonic response analysis, we get oscillations, natural frequency, and as a result of it, we can estimate the oscillation amplitude as for conventional machining, as for machining with a fluid jet support. Next slide, please. So formulation of the fluid jet support technique. Based on Bernoulli's principle and continuity principle, we get impact of the jet force. Also, it is defined the speed of the flow, and we define that with a hub of a nozzle diameter, it's 4 times higher. The pump pressure, of course, is constant, but there are different types of pressure in the flow: static, dynamic, hydrostatic pressure. So by increasing the speed of the flow, we increase dynamic pressure component and accordingly the kinetic energy of the flow. So the high force impact on the thin walled part. Next slide, please. Theoretical possibilities of implementation. First of all, major impact of fluid jet support is natural frequency increase. There is a type on the slide, reduction of temperature in the cutting zone, and increase in part deflection resistance. There is existing equipment, for example, for breaking of the chip in the process of machining. So the units that can supply such kind of high pressure are commonly used in production. Another point, using optimized nozzles with small diameter gets flow closer to steadier laminar, and the smaller nozzle diameter, the higher flow speed. So equipment lower energy consumption. Next slide, please. Simulation with smooth particle hydrodynamics is a method that's suited for simulation of cases when be dominated by complex boundary dynamics, when the surface flows are free and the boundary displacement is really large. So also another advantage is that computational costs of SPH method per amount of particles is significantly less than for grade-based method. Each particle carry attributes including mass, position, velocity, etc. The continuous flow field is dispersed as a large of moving fluid particles. As a result, we got the value for the force deflection. For different nozzles, we noticed that deflection with the nozzle 2 millimeters diameter is near 6 times greater than 4 millimeters in diameter. The input parameter was pump pressure, and gap between nozzle and the wall was 2 millimeters. Next slide, please. So cutting finite element analysis. We performed it for the quarter of the part to reduce computational costs. We used as a material aluminum alloy. The width of the cutting was near 3 millimeters and the depth 1.5 millimeters. We got stress and finite element analysis cutting force, which is equal to 210 newtons. Next slide, please. So modal and harmonic response finite element analysis. The main goal of the harmonic response analysis was to prove our assumption that by applying additional support, we not only decrease the amplitude of the oscillation and external cyclic load, but also it will lead to the shift of the natural frequency of the structure. Consistently, we get more frequency space for the cyclic load without negative resonance impact. So we applied the force to the wall from the side of the milling in both cases for machining with support and without it, and analyzed a case when we apply machining plus additional support to the whole back side of the wall. And we noticed by the values that there is a shift in natural frequency. You can see it from the slide. The points that we took into account in frequency measuring is spindle speed, cutting force, number of cutters, and we got this amount of reduction of the oscillation. Next slide, please. So conclusions. As a conclusion, the technique can be organized on existing equipment basis. There are a number of existing units. The approach in this research proves the ability to apply SPH method, and we performed comparison between different nozzles. We got the force of the impact force of the flow for most efficient nozzle, and we performed harmonic response analysis, and most of all we observed the shift of resonant frequency on the graph. Thank you for your attention.
Thank you very much to Sergey. Nice presentation, nice speech, and interesting research results. Personally, I'm familiar with your research because I saw it during last conferences in Ukraine. As I know, you are on the finish of your PhD thesis, and we wish you to complete it as soon as possible and defend it.
Thank you very much.
No questions in the chats, so thank you very much and good luck in your future research results.
Thank you.
Thank you. Bye. At this moment, we are waiting for the next speaker, Vasily Larshin, professor of the Manufacturing Engineering Department from Odessa National Polytechnic University. He is a well-known scientist in abrasive processing of materials, and he represents the presentation from the team of scientists from Odessa National Academy of Food Technologies, Odessa National Polytechnic University, Odessa State Agrarian University. His presentation titled Finite Element Analysis of Profile Gradient Temperature, and Professor Larsen is now on the connection. Professor Larsen, are you here? Maybe some technical problems. Professor Larsen and his team is a participant. Dmytro, are you here? Dmytro Lesik? I would like to make some technical break for 5 minutes, and we will back in 5 minutes. Дима, Дмитрий, вы здесь? In 1 minute, I will start and present you, and you will start your presentation, okay?
Okay, thank you, Vitaly.
Юрий, скажите, когда можно будет, начнем?
Вы мене чуєте?
I'm sorry for technical problems, but we are online now, and I would like to present. It's my pleasure to present the next report, and this is very interesting research because it's based on several research teams. Our speaker will be Dmytro Lesik, who represents National Technical University of Ukraine, Igor Sikorsky Kyiv Polytechnic Institute, but he cooperates with University of Basque Country from Spain, and also industrial company Motor Sich, John Stock Company, and Kurdumov Institute for Metal Physics of the National Academy of Sciences of Ukraine. Dmytro is the participant since 2018. Every year he presents very interesting research, and today he would like to deliver the speech titled Combined Thermomechanical Techniques for Post-Processing of the SLM Printed Nickel Chrome Ferrum Alloy Parts. Dmytro, please start.
Yes, thank you very much, Ivan, for such presentation. Hello, dear participants and guests. My name is Dmytro Lesik, and I work at the Department Laser System and Physical Technologies at the Kyiv Polytechnic Institute, and I would like to present you a study on the topic Combined Thermomechanical Techniques for Post-Processing of the Nickel-Based Alloy Part Printer by Laser Powder Bed Fusion. It should also be noted that academic and non-academic collaboration was applied during this work because some tests were conducted using industrial equipment. Manufacturing industries are always looking for improving techniques to lower cost, energy, and expand their ability. Contrary to the conventional manufacturing that often requires machining to remove excessive material, additive manufacturing or 3D printing allows for expanding manufacturing facility. There are several advantages of additive manufacturing. For example, metal additive manufacturing is a good approach to the producing of complexly shaped parts that need to be strong and lightweight. Nevertheless, thank you. Nevertheless, improvement in the properties of the metal components fabricated by different additive techniques such as wire and arc additive manufacturing, electron beam melting, laser metal deposition, laser powder bed fusion, or selective laser melting is very relevant. It's well known that the poor surface roughness, porosity, and tensile residual stress of the fabricated parts may limit the wide application of metal-based 3D printing techniques, despite their vast potential. As a result, the development of new post-processing technologies is required to reduce or eliminate the superficial and volume defects in metal parts. Next slide, please. So, the aim of this work is to develop the thermomechanical technique for the post-processing of nickel-based alloy parts fabricated by selective laser melting process. And the research tasks are the following: study the surface texture, analyze the surface roughness parameters, and evaluate the surface hardness. Next slide, please. So, in particular, in this work, a nickel-based Inconel 718 powder with particle size distribution in range of 1055 micrometers as feedstock material. The nominal chemical composition of the powder used in given in the table 1. In particular, the flat parts were fabricated by, please, the next slide. Selective laser melting technique using a laser power of 200 watt, laser spot of 70 micrometers, and the laser scanning speed of 700 millimeters per second. General view of the SLM machine and scheme is presented on slide. Next slide, please. To eliminate the internal porosity and increase density of material, all SLM built specimens were subjected to the hot isostatic pressing treatment. The heat treatment consisted of a heating temperature of 1160 Celsius degrees and a pressure of 160 megapascals for 3 hours. Next slide, please. Then the heat processed specimens were subjected to both a double edging process and gommonization heat treatment, followed by double edging heat treatment according to a standard. In particular, the gommonization heat treatment was performed at the heating temperature of 1180 degrees Celsius for 1 hour using a vacuum furnace. The edging heat treatment parameters are listed on the slide. Next, please. So, two mechanical post-processing techniques such as conventional shot peening and ultrasonic impact treatment were applied in the optimized parameters for surface treatment of heat-treated specimens. The schemes of the shot peening and ultrasonic peening process are shown on the slide. Next, please. So, surface topography of the SLM built and heat-treated specimens is given on the slide. It can be seen that manufacturing surface defects such as ellipsoid or spherical balls, partially melted powder particles, open pores, as well sign of laser tracks remain on the surface after post-heat treatments. Next slide, please. Both shot and ultrasonic pinning after heat treatments led to a significant change in the shape of the surface profile and form a new wavy microrelief. As compared to the shot pinning process, the wet process on the left side forms regular microrelief with smoother surface roughness and lower surface waviness, owing to application of the multi-pin ultrasonic tool, which produces the sliding impacts of pins by the specimen surface due forced rotation of the impact head. Next, please. At the same time, the maximum height parameter of the ultrasonic processed specimens was decreased by approximately 4 times in comparison with the heat-treated specimens. Next, please. The surface hardness of the SLM-built specimens is increased after application of old post-processing techniques. In comparison with the heat-treated specimens, the surface hardness in the near surface was increased by 20% after the ultrasonic impact treatment, while the shot-treated specimens is slightly higher than that of the wet processed specimens. Next, please. So, combine thermomechanical techniques for post-processing both complexly shaped and large-scale or small size nickel-based alloy parts fabricated are processing techniques after heat treatments led to formation a new wavy microreliefs. As compared to SLM specimens, the combined treatment increased the surface hardness by 60–70%. Next. That is all. Thank you very much for your attention. I remember, yeah.
Thank you very much. Thank you very much to Dmitro for your presentation. Very interesting research. I am checking the questions, and at this moment, no questions on Facebook and also on YouTube. Thank you very much, and looking forward to seeing you next year during 2021 conference. Thank you very much.
Thank you very
much.
Bye.
And now I would like to represent the next speaker of our conference, Professor Larshin, Vasily Larshin from Odessa National Polytechnic University. He represents a team of scientists from Odessa National Academy of Food Technologies and Odessa State Agrarian University. The title of his presentation is Finite Element Analysis of Profile Gradient Temperature. Professor Larshin, please start your presentation.
So, Professor Larshin, do you hear me?
Yeah,
Professor Larshin. I can begin?
Yes, you can start.
You can start. My best regards to all participants of the conference. I am from Odessa. Odessa is the second capital of Ukraine. We are understood. Okay. The topic of my presentation is finite element analysis of profile gradient temperature. There are three authors of the representation. This is the first slide. Introduction. Temperature excess leads to grinding effects. Please, temperature. This is the first point of this slide. Grinding burns extending to a depth 100 micrometer cause a decrease in the surface hardness from 60 to 51. This is next slide. Next slide. Aim and tasks. Come back, please. This is next slide. It's convenient. It's necessary to stand my slide number 2. Number 2. Okay. Да. Сейчас слайд скачем. Давайте. И отвечаем. This is Odessa. Odessa National Polytechnic University. There are three authors in this presentation: Natalia and Sergei Uminsky. The slide shows that temperature excess leads to grinding defects, grinding burns and cracks. When T more than T critical. Methodology. It's convenient to take the thread surface of the lead screw with a unisecular thread profile as a profile grinding example with different profile curvatures. The following analytical equation was taken for the case in question. There are several variables in this equation. R is the current radius vector of the surface point. Q is the heat flux. R is the cylindrical surface radius. Lambda is the thermal conductivity of the workpiece material. Two parameters, 0 and 1, are Bessel functions of first kind of 0 and first order. And these two parameters are Bessel functions of second kind of 0 and first order. Zeta is integration variable. The next slide number 5. Slide number 5, please. This is closest analog with the flat surface. You can see this equation on slide number 5 because I have not seen the slide. X is the current coordinate, which is at perpendicular to the heat surface. A is the thermal diffusivity of the workpiece material being ground. For the equation 1 to determine the depth of the temperature penetration into the thread surface layer, it's necessary to take into account the formula. Next slide is number 6. Number 6. Please, number 6. This slide shows the temperature calculation by analytical solutions 1 and 2. The temperature calculation is performed with using the formulae 1 and 2 for different radius of the profile being ground in the range from 1 to 6 millimeter, and for different values x from 0 to 0.6 millimeters. Conclusion: the first, the more radius, the more grinding temperature in Celsius, in degrees Celsius. And the second, the solutions 1 and 2 are about equal each other when radius tends to infinity. The next slide is 7. This is implementation in the COMSOL multiphysics program. You can see equation number 4, in which rho is the material density, C is the specific heat capacity, U is the velocity vector, nabla T with a dash is the temperature gradient, Q is the heat flux vector, Q large is the heat source power per unit volume. The velocity vector can be written as, and you can see this equation, where U, X, U, Y, and U, Z are components of the velocity vector in the thermal conductivity medium. I, J, K are single vectors or chords in Cartesian coordinate system. The next slide, number 8. 8 shows result of frame simulation. The first, in the COMSOL multiphysics program, a geometric model, see figure 2 left, with different circumference radii is created and a temperature distribution is obtained. Figure 2 right. Second, it was found that when the radius of curvature of the grinding surface is more than 6 millimeters, when grinding steel, the influence of the curvature on the grinding temperature would be neglected. The next slide, please, number 9. Shows comparison of the analytical and frame models. The first point is temperature distribution on depth obtained for the flat surface is shown in figure 3. Second, the comparison is shown in table. You can see the table. The difference here is no more than 0.4%. And third, in general, other conditions, the difference may be 2%. Hence, the difference may be from 0.4 to 2%. The next slide, please, number 10. Number 10 shows frame simulation mechanism and its opportunities. It's necessary to say the first. In COMSOL multiphysics, the temperature field is obtained based on the solution of the differential heat equation in the partial derivative. Second, the number of this equation is determined by the number of sections of which the contact zone is composed. within in each section the required initial and boundary conditions operate, and these conditions change discretely when moving from one section to another. And third, with PEM simulation, it's possible to take into account a variable heat flux within the contact zone and the boundary conditions of the second kind, as well as instantaneous curvature of the profile to be ground, etc. The next slide, number 11, shows areas of practical application of the work. On the left, you can see profile key grinding. In the center of the slide is sample from the tools of the key. And here is the microscope result. Conclusion. The first area of practical application is profile key grinding. The second area of practical application is semicircular thread profile grinding. And conclusion. The next. Turns determination is a difficult problem. It's preferably to study grinding temperature instead of grinding turn. The next slide, number 12. Number 12 shows our conclusions. The first, briefly, the grinding temperature is one of the factors limiting the performance of the profile grinding operation. Therefore, the temperature information can be used to optimize the grinding parameters during both the production and production preparation stages. Second, FEM consists in geometric modeling, that is, creating a model, and virtual simulation and studying the temperature field using the geometric model of the object and vector form of the Fourier law of thermal conductivity. Third, the difference between the estimates of the temperature field by the analytical scala and simulation vector model of the temperature field does not exceed 0.5.
Some technical problems. Professor Larsen missed, unfortunately, and unfortunately we
our connection. Then where is our connection? Do you hear me?
Yeah, we are hearing you.
I am continue.
Yes.
Yes. It is slide number 12. I'm speaking about conclusions. The fourth conclusion is when the grinding surface curvature radius is more than 6 millimeter, and when grinding work is of steel, the influence of the curvature on the grinding temperature can be neglected. And last conclusion is analytical model with a linear profile as opposed to a curved profile can be used to determine the maximum temperature of profile grinding when radius more than 6 millimeters and Peckley number more than 4. The next slide is 13. This is an acknowledgement. It's necessary to say about two things. The first, this work was carried out in accordance with state budget team of Odessa National Polytechnic University. And the main acknowledgement is that this work is dedicated to the 55th birthday of Professor Alexander Vasilievich Yakimov. He was born March 16, 1925. Professor Alexander Vasilievich Yakimov is the founder of the Scientific School on Grinding Technology and Automation of Grinding Operation, including intermittent grinding technology. And the next slide is 14. Thank you for your attention. I am ready to hear you.
Thank you very much to Professor Larsen. Thank you very much for your research. Despite on technical problems, he completed the speech. Thank you.
Thank you very much.
Yeah, I would like to highlight that Professor Larsen is an expert in grinding technology, and as he mentioned, he belongs to the scientific school of Professor Yakimov, who was the founder of grinding technology and automation. There are no questions in the chat in YouTube and Facebook, and so we can say that all presentations from this session were completed, and we can make some summary. It is the idea to proceed to the final part of our conference and start the closing and awards ceremony. And hello? Не показывать диплом. Okay, we would like to make some summary regarding our conference, and during this edition we accept 93 papers that were published by Springer Nature in 2 volumes. This was allowed because several thematics were investigated, and the first volume was devoted to manufacturing and materials engineering, the second volume dedicated to mechanical and chemical engineering technology. So 93 papers were already indexed by Google Scholar and ResearchGate. We expect indexing by Scopus database this month, and we are still working on the indexing this book by Web of Science core collection. This is not easy process, but we can successfully done it during last 2 years, and we expect it will be in near soon. To make some summary regarding this conference, during 2 days, 5 keynote speeches were delivered, 19 oral presentations from all areas of the conference were covered. There are mechanical, manufacturing, materials, chemical, and interdisciplinary research were presented. 67 posters were published and presented at our website. You can you can see the research results of the research teams. We would like to renew our tradition and make awards for best poster and best presentation awards. In our opinion, it's a great tradition and the promotion of conference for future events. The official voting was completed today at 10 a.m. and we have already calculated the results of your voting and would like to announce them right now. So the best poster award was devoted to the team of researchers who represent very interesting research. The research dedicated to the research dedicated to method of design of interference fit based on complex mathematical modeling. The names of the Poster authors Vladimir Nechiporenko, Valentin Salo, Petro Litovchenko, Vladislav Yemanov, and Stanislav Gorelishev, who represents National Academy of the National Guard of Ukraine. Congratulations. And it's opinion of all participants. It's not opinion of DSMIE team. It's thank you very much for your participation. Thank you very much for your contribution. You can contact our team how to receive the physical certificate. Thank you very much. And the next award that was very difficult to find, because there are a lot of interesting research and presentations from all over the world, but the session chairs made their decision regarding best presentations from their sessions. Based on this discussion, the best presentation award was selected. And this award will be sent to the speaker as soon as possible. And this year, this award is dedicated to representative of AGH University of Science and Technology, Yulia Tarasevich, who presented her research in mechanical engineering session with the title Estimation of Random Flow Rate Characteristics of the Automatic Balancing Device Influence on Centrifugal Pump Efficiency. It was interesting presentation, interesting discussion, questions, and in opinion of our society, it's the best presentation this year. Thank you very much for your participation, and looking forward to seeing you next year during the conference in 2021. It is we are still organizing the next year's edition, and we expect the next conference. The next conference will take place in Lviv, western part of Ukraine. I think it's a good tradition when the first edition of conference was in Sumy in northeastern part of Ukraine. The second edition was in Lutsk National Technical University at the western border of Ukraine. The third edition in Kharkiv online Sumy. And also the fourth conference will be in Lviv next year, second week of June, traditionally. So the call for papers will be announced in July, and it will be closed in October 2020. So you have enough time to prepare papers for this event. We will use EasyChair system, and we expect to announce the results of papers before New Year. We need it because our tradition to publish papers before the conference. It's our principle to get acquainted with papers for all participants. I would like to remind that all papers are published this year, and you can find full texts via our website. Please go to the sub-menu schedule proceedings, and you can see the direct link to Springer websites. But using our website, you can get free access to all papers. If you have any problems, you can contact our team after the conference, and we will help you to find your paper in PDF format. Thank you very much again, and I would like to highlight that this year's conference faced with challenges in COVID-19, and so online format is not usual for us, and I hope we solved it, and everything was successful. Thank you very much. And I would like to say that now we have to say goodbye to the next year, to the next edition of conference DSMIE 2021. Thank you very much.